Hey everybody, Mr. Bells here. This video is for data analysis, and today we're going to talk about normal distributions. So hopefully you guys remember we learned about this statistic called standard deviation, which talks about how big of a spread there is in the data. Well, it turns out we can use these things called standard deviations to see how far somebody is away from where maybe the typical amount would be. So first off, we have three different types of distributions that we're going to look at. One would be called skewed to the left. So for you guys, it would look like this and kind of go like that off that direction, or skewed to the right. So it's whichever way the tail goes for those things. So sorry, I think I might have done that backwards for you. I'll draw the pictures out too with it. But the big one's a normal distribution. Normal distribution is kind of high in the center and then tails off just like this. So lots of data in our world follows something called a normal distribution, like people's heights around the world, or people's IQs, SAT, ACT scores, kind of follow this thing called a normal distribution. And we're going to be able to use that with standard deviations to learn a lot about statistics. So I'd already started this video and then I got a phone call a few minutes ago, so I had to start over again. Hopefully this will be good for you right here. So first thing I'm going to remind you is this big formula for standard deviation. Standard deviation measures how far, numerically speaking, how far data points are spread apart from each other, right? So here's two symbols. There's this new little thing right here that's called mu. And mu is the mean of a data set, a specific data set. So when we talk about x bar and we talk about mu, for our class at least, we're going to kind of say that those are like the same things. Okay? Now, this is a normal distribution. Normal distributions are peaked high in the center and they kind of tail off. So it would kind of be like right over here. This if I was to do heights for people on the planet, Yao Ming was a center in the NBA, and he was about 7'6", 7'5", 7'6". Yeah, that's really tall. And then maybe some Oompa Loompas from Willy Wonka, some people that are a little smaller. There's not a lot of those, and there's not a lot of those, but there's a whole lot of people in the 5'8" to 6 foot region around the planet. Okay. And what we can do is we can say that if something is under a normal distribution, that we would expect a certain amount of those people, a certain amount of percentage of the population, to fall within plus or minus 1 standard deviation, or plus or minus 2 standard deviations, or plus or minus 3 standard deviations. Okay? And as we go through this, I'm going to talk a little bit more about that. Now, you could physically actually count these boxes. And when we count these boxes up, you're going to get really close to about 68 boxes. If we counted these boxes up, we're going to get really close to another thing. And on the next page, I'm going to show you the breakdowns of it. Okay, so let's go to this little chart right here. And if you needed to, you could take a picture of this. You could pause the video, whatever it is. So this was a study done in Scotland in the mid-1800s, where they measured chest sizes of men in the Scottish militia. So we're talking about the military. They did it for 5,738 men, and they just measured how big it was around their chest. Okay, so you can see that there were size 33-inch chest, which is pretty small. It's smaller than my waist. There were only 3 of them. So they were pretty tiny, thin guys. And 48, that's a big barrel-chested person. There's only one person at 48 inches. But right here in the middle, in this 39, 40, 41 range, you can see there's almost 1,000 people in each one of those categories. Well, if we put them here in what we call a histogram is a chart that shows interval gaps on the x-axis and stacks of how many people are on the y-axis, and it's kind of, you can see this, right? It's kind of following that normal distribution that we just said, or a normal curve that we just said on the other one. So if we were to do this and look at this and we go, wonder what the standard deviation is. Well, it says the standard deviation is 2 inches. Now, you would have to put all 5,738 of these data points into your calculator and do the one variable stat, and it would give that to you. There's also a way to be able to just put in these numbers and then put in these numbers in L2 and call this a frequency list, and then it would treat it as 33, 33, 33, right? And then 34, 34, 34, 34, 34, 34, 34, 34, 18 times, and then put in 81 35s. So you can kind of tweak your calculator to be able to do that, but we already have it. So the average chest size is 40 inches and the standard deviation is 2 inches, which means that if we were to have our mean here at 40, right, our x bar or our mu here at 40, then I could go out one standard deviation to 42 and one standard deviation down here to 38, and there should be a certain amount that falls in that range. Remember, the whole thing looks like this, so there's a certain amount that falls within that range. So what we're going to talk about on the next page is actually what those percentages are, okay? So here we go. This data down here at the bottom is really important to us. It says, under a normal curve, the total amount of area is 1 or 100%, okay? And that in these three ranges, one standard deviation out is 68%. 68% of the people fall within plus or minus one standard deviation of the mean. And then going out one more standard deviation, so you're plus or minus 2, 95%. And then plus or minus 3 is 99.7%. And these are facts that you definitely want to have in your notes. And this isn't true for just the Scottish militia chest sizes. This is true for everything that is a normal curve. Again, not skewed, right? We can't say that this is true for data that looks like this or data that looks like this, right? That's skewed either to the right, this is right skew, or skewed to the left. This is left skewed. But it does work for stuff that's normal, like this, okay? So how do those percentages work out? Well, if there's 68% in the middle, that means that there's 34% in each one of these two halves, okay? Each one of those two halves. And then you can see that there's 13.5 and 13.5 here. Well, if you added that up, that would be 27, right? 27 and 34 gives you a total of 95. So that's why that's 95 in that area. Then you got 2.35% in this next section, 2.35% in this next section. And then in this, and this goes out to infinity, because we never know how far it's going to be in somebody in that direction. Maybe there's one that's really just way out there, that's just not normal compared to everything else. We call that an outlier. It's 0.15%, 0.15% in all of those tails. So it could go out 4 standard deviations, 5 standard deviations, 6 standard. So the sum of all of those is 0.15. And you can see that 0.15 and 0.15 from this range is 0.3, and that's the leftover after the 99.7%. Okay? So now we're going to try and answer some questions with some notations here and see if this follows for you. And this is going to be really important for you to be able to do the homework and the online stuff. And again, please, you do the homework. Don't let some text thingy. So this says, in a normal distribution has a mean of mu and a standard deviation of that. Find the indicated probability for a randomly selected x value from the distribution. Well, that sounds kind of sketchy. But this is basically saying, what is the chances that your score, X, is less than or equal to the mean minus 2 standard deviations. So here's a normal distribution, right? There's our mean. There's 1 standard deviation. There's 2 standard deviations. And it wants to know what's the chance your score is less than or equal to 2 standard deviations below the mean. Okay? So what I do, I go over here and I look at this and I go, I know that at the halfway point right here, that's 50% going to the right. So I can't have that. So there's 50. And then I can't have this, that's 34. And then I can't have that, that's 13 and a half. And if I add all those up, that's 84, 97.5. That's 97.5% that I can't have it. Or you could have looked at it this way. I just needed to go in this bottom section, which is 2.35 and 0.15, or 2.5%. So the answer to question number 1 is 2.5%. That's the probability that somebody would score 2 standard deviations below the mean or lower. Okay, that the score X is less than or equal to a negative 2 standard deviation mark. Again, so this is our mu. This is minus 1 standard deviation. This is minus 2 standard deviations. This wants to know when its X is less than that. Okay, so now this one says, how about when X is greater than 3 standard deviations below? So let's draw our little chart in here. So here's our middle. Here's 1 standard deviation, 2 standard deviations, 3 standard deviations. Remember, beyond 3 standard deviations over here, that's only 0.15%. And we want to know when is it greater than that? So that would be all of this, right? Be all of this. So it's everything but 0.15, so it would be 99.85%. Okay? The chances of you scoring greater than or equal to 3 standard deviations below the mean is all of the stuff that you see there. Okay? And you could practice on these ones here. You could read the book. Oh, that'd be awesome too. You could read. I'm going to do one of these examples down here, because this one's a little bit different. So this one says, what's the probability that your score falls between negative 2 standard deviations and positive 1 standard deviation? Okay, between negative 2 standard deviations and positive 1 standard deviation. Okay, so let's do this. So here we go. Positive 1, that's 34%, right? To negative 1, that's 34%. To negative 2, that's 13.5%. So we're trying to go from negative 2 to positive 1. So that's any place in any of those regions. So I just need to add those up. So 34 plus 13.5, 68 plus 13.5, 0.58, 9, 10, 11, carry 1, 6, 7, 8, 81.5%. So that answer would be an 81.5% chance. Okay? So hopefully we're at least finding out what that means. So that's saying that if we actually did some data here, that we would know that a typical person, their score 81.5% of the time would fall between negative 2 standard deviations and 1 standard deviation. And this data could be anything. Okay, so here we go. Here's an actual example. It says the scores for a math course test are normally distributed with a mean of 61 and a standard deviation of 11. The test scores range from 0 to 100. Okay, so this is what I'm going to do. I'm going to mark from 0 all the way out here to 100. And I'm going to say, hey, this is where they could fall. But it says it's a mean of 61, so I'm going to go to 61. and it's got a standard deviation of 11. So go 11 up, so that would be a 72. 11 up again, that would be an 83. 11 up again, that would be a 94. Those should all be the same distance, so I'm pretty close on this. 11 down would be 50. 11 down more would be 39. And 11 down again from that would be 28. Now we said it was normally distributed, so the high point has to be right there. And it's got a curve like this and like this. Oops, sorry. It should have been more normal. Looks a little bit better that way. Ignore that portion of it. And it says, about what percentage of the students taking the test have scores between 72 and 83? Well, 72 and 83, 72 and 83, this is this section right here, right? Well, that's +1, that's +2. So what percentage of the students fall between that range? We know from our little chart over here that that is 13.5%. So answer 13.5%. Now it says, about what percent of the students taking the test have scores less than 50? Well, less than 50 is right here, and that's at -1 standard deviations. And I think maybe it works out best for us this way. We know that on that half is 50%, and this section is 34%. So if we want to know what is in this tail right over here, this section from here, it's everything but the 50 and the 34, so everything but 84, and that would be 16%. And that 16% is comprised of the 13.5, the 2.35, and the 0.15 that goes on forever here. So here's just kind of a general thing. Let's say that there were 30 kids in the class. 30 kids in the class. Would you believe that 10 of those kids got a 95 on this test? And the answer to that would be no, that's impossible, right? 95 right here is in this range. There's less than 0.15% of the students that would get there. So I can't have 10 out of 30 get a 95 on this test. Does that make sense? So using these curves really kind of help us understand where people will fall. So if I was in a group, let me just take a here. So if I was in a group and I said, hey, maybe for, let's say, hockey ability. For me, for hockey ability to be able to skate and play hockey, my standard deviation in terms of skill levels for a whole bunch of hockey players would probably be at a -2.5 or -2.5. Okay, so -2.5 means that my skill levels for hockey are pretty stinking low compared to hockey players. Now, where if I said the same thing again for maybe something that I do actively play a little bit more, like bowling or tennis or volleyball, baseball, softball, football, all of those types of things, I would say that my standard deviation in terms of skill levels for the general population might be in the positive range. Okay, some of them might even be pretty good. So a standard deviation kind of sets you up for where you are with everybody else. Now, if it was talking about, let's say this one, high school games coached, if I was looking at that for the general population across the world, and we talked about how many high school games that you coached, I've been around a long time. This started coaching in 1993. So we're talking about 27 years, multiple seasons. I'm close to 1,500 games. I would probably be at about the third standard deviation, fourth standard deviation, which means I've coached more than probably 99.9% of the people that are out there, okay? Because I've been doing it for so long. However, that distribution wouldn't be normal. You know what I'm saying? Would not be normal. Because of the fact that we have tens of millions of people that haven't coached anything in high school, right? Hundreds of millions of people across our planet that don't do that. So then you'd have to just look at people that have coached, and then you go, okay, so are we going to still have that giant curve right in the middle? And that might be possible, but I think we're probably going to have a lot more on the small end, because some people get into it and realize, man, that's a little bit too hard. You got to give up a lot of time away from your family and a lot of other things. And it's not a lot of people that are going to go for about 10 years and say, we're good. Okay? Again, probably that data isn't normally distributed. So these percentages, the 68, 95, 99, 7, only work for data that is a normal distribution. Okay? Here, spin that for you. So you can see that on 11.1, there's going to be a couple more things, and I want to give you this one too. It says the temperatures of a city are normally distributed over the course of a year. The mean temperature is 55.2 degrees and the standard deviation is 6.3 degrees. A day is randomly chosen. What's the probability that the chosen day is 45 degrees or cooler? Okay. So what we would need to be able to do on stuff like this is kind of get yourself a little curve, right? And we go, the mean is 55.2, right there, 55.2. And it says standard deviation is 6.3, so if I add 6 to that, that would be 61.5. So 61.5, and add 6.3 to that, that would be 67.8, 67.8. And then I do the same thing, I go backwards over here, and go backwards over here. So 55.2 minus 6.3, and it's okay. You guys can do this. You can go to your calculator and you go, hey, what is 55.2 minus 6.3? I get 48.9. And then I do the next one, and I minus 6.3 again. Hit enter and I get 42.6. And these are the temperatures that are falling within 2 standard deviation. I could go at 3 standard deviations, and that would take me to the 99.7% of the population. So this says, what's the probability that this chosen day is 45 degrees or cooler? 45 degrees or cooler. So 45, that's right in that range, right? So I know that it's at least -1 something. I just don't know exactly what this is. So what I do is I find out what its z-score is. And a z-score is x minus x bar divided by standard deviation. So I'm going to take that score, 45 minus that mean, 55.2. Enter, got to hit enter. And I'm going to divide it by the standard deviation, 6.3, enter. And I get a z of -1.619. You're like, oh, that's awesome. So then there's actually charts in your book that allow you to find out what the percentage is for a -1.619. And I'm going to grab a data book right now. It's right here. And I'm going to find that little chart for you. Flipping through. Okay, this is called a standard normal chart, and you can see that it has z-scores, and it talks in your whole book about the same stuff that I just did and everything. So I would read it, okay, right over here on the bottom of page 597, that talks about the standard normal distribution, the z-scores, x minus mu. Again, x bar I've used as a symbolism for that for a long time. So you can go either way with it. But what I'm going to use right here is this. So if I need to find out what a negative 1.619 is, I'm going to go right here. So I'm going to go negative 1, right? And then I'm going to go out here, negative 1.6. So that's a 0.0548, 0.0548. So one more time. So negative 1. And then I go out to 0.6. Again, that's as close as what this chart's doing. Negative 1.6, 0.0548. I'm going to go ahead and write down that number. That's a 0.0548, or basically about 5.48%. Okay, well, if that's 5.48%, and I want to know what's probably the chosen day is 45 degrees or cooler, that's this direction, then it's 5.48%. If I chose this word, 45 degrees or warmer, that would go the other direction, and I would simply take 100, right? Clear 100 minus 5.48, and I get 94.52% chance that it was going to be warmer than that day. Okay, again, that's on a randomly chosen day. So this one says, what's the probability that the chosen day is cooler than 32.5? And I want you to try right now. So try that on your own before I go ahead and do it. This is going to be the last one that we're going to do. So we're going to try 32.5. Okay, so stop the video, find out your z-score, look up your percentage on the thing, and we'll go from there. Okay? Okay, I'm back. So I'm going to do 32.5. So I got, all right, and again, 32.5, that's way down here. That shouldn't, I mean, that's pretty stinking cold, right? It's not going to happen much in this city, wherever this city is. So I got 32.5 minus 55.2, enters, negative 22.7, ooh, divided by 6.3, that's negative 3.6 standard deviations. Oh my gosh, that's like way out here, such a tiny, tiny, tiny little tail. So I go to my chart, and I go to negative 3, and I go to 0.6, and I get 0.0002. 0.0002. Or 0.0002, or move it to change it to percentage, right? 0.02% chance. Which means it shouldn't happen, right? It's the chances of it being 32.5 degrees in this city over that course of that year, it's almost impossible. It's never going to get that cold there. It's like, I don't know, maybe in Los Angeles for the temperature to be like -4, right? Chances of that happening are so small. You know, it snowed there before, I believe, but it's not going to get that cold. Okay? So hopefully this helped for you in terms of this normal distributions. Make sure you read the book if you need to, and we will talk to you later.